Okay, to reinforce this further, I'm going to send a second application across these sense nodes in the network. Something more useful, something which is going to actually sense temperature and send it back to me. So I'm going to use exactly the same procedure that I did with the blinking light application to do this. So again, I'm going to use netcommander to add some more files to the dissemination service. So this time I need a sensing application and the component which goes with that. And I also need a temperature sensor driver, because again, that does not yet exist on these nodes. Like this. And finally, again, I need an evolution script which describes how to integrate these components into the system. And this looks very similar to the one that I just showed you. Okay, so again now, all these files are being sent over the radio to the other nodes, and once they all arrive, will be loaded into the running system. So for now, I'm actually done with netcommander, so I can exit this and go back to the shell. And what's going to happen this time, when all these files arrive at these nodes, is that the sensing application will, every second, sample the temperature and then send that value over the network. So to be able to receive those values, I need something running on this node which can listen on the same port and print out the received values. And to do that, I'm going to add another kind of component here called senseReport to the shell node. Okay, again, that happens very quickly. And unlike the netcommander application, this one does not take command of user input, so I can still type things like RS, and I can see the whole software now running on this shell node, which includes senseReport. Okay, the other thing to point out here is that the whole time that file transfer is taking place here, the blinking light application is still continuing to function on these two nodes. And that's another kind of property of update independence that we have, where the services that were already running on these nodes continue to function the whole time that new services are arriving. And so again, this will just take a moment, and as soon as the sensing application is installed, then we'll start to hopefully see some sensor values printed out on the terminal behind me. Okay, this usually takes a little while to happen. So this is actually using a low power file transfer protocol. The amount of data actually being transferred here is something like 1,000 bytes. So it's not very big, it's just doing it with very high energy efficiency. Okay, so there we go. So now we see that one of these nodes has received all these files and is sending out sensor values to me, telling me that the temperature in the room is about 20 degrees. Okay, so as one final demonstration of this technology, I'm now going to try to show you just how much of software is amenable to exactly the same model of software evolution. So first of all, I'm going to just remove the random number generator, okay, using the remove command, so remove random. So I press enter, and as soon as that happens, I will stop receiving sensor values from the network. And that is because if I type ds, I see that although senseReport is still here, it is no longer connected to MAC because MAC is missing a dependency. Okay, so the two nodes in the network are still sending sensor values to me, I'm just not listening right now. So while we're here, I'm going to now show you how to modify some of the other files, some of the other components rather, in the OS. So if I look at the currently running software, we see that we have a dynamic loader and we have a scheduler, among other things. So now I'm going to show you that we can replace even the most fundamental things here, like the dynamic loader, with something else. Okay, and we do this using another of the evolution primitives, this one called replace. So I'm going to type replace loader with new loader. And again, the new loader thing is something which is already in external flash memory. And you can imagine doing this, for example, if you want to swap the current dynamic loader for one which either loads components over the network or does some extra kind of security checks on the components being loaded to check if they are safe to load. But in this case, the replacement loader is something which is just going to print out some debugging information about when it loads and unloads components. So when I press enter here, what's going to happen is the old loader, the current loader rather, is going to be used to load the new loader. Then state transfer will happen between the two loaders, and then the new loader will be used to unload the old loader. Okay. So the effect of this is that I press enter, and the new loader says I'm now unloading the old loader. Okay, so that shows you that it did in fact integrate a new loader into the system. To further reinforce this, I'm now going to show you how to replace the scheduler in exactly the same way. So again, you can imagine doing this if you want to change the scheduler to something which uses a different model of scheduling. For example, a different priority of scheduling, or even replacing it with something as extreme as a multi-threaded scheduler. But again, in this case, the new scheduler is just one which prints out some extra information about how it works. So I press enter, and again, this happens very quickly, and it happens completely online. Okay, so now when I press enter, what we see is the new scheduler telling me when a task is being run. And so it says running task for serial.so, which makes sense because when I press enter, the serial port driver is the thing which receives data and delivers it to the shell application. Okay, so finally I'm now going to add the random number generator back into the system. And this will immediately start up the sense report application, so I'll start receiving sensor data again. And you'll also see the scheduler, when I do this, is in fact very busy. So this shows you that, okay, that we see a sensor value go past. And the reason it's so busy is that the MAC protocol we're using right now is a low power listening protocol, which does very fast timing. So you see lots of events coming in from the timer. So hopefully from that you see that in Lorien we really can change from any software architecture to any other in a way that's completely seamless, completely online. And we can change even the most fundamental pieces of software. We can even change things like file systems, dynamic loaders, and schedulers, while the whole system remains online with really strong integrity and really strong independence between different changes. So this ends a quick introduction to the Lorien OS, an OS fundamentally built to evolve. So hopefully you've seen that we have an OS which supports whole system software evolution, from drivers all the way up to applications. And we have very good integrity guarantees, meaning that even fundamental software changes will not break the running software. We also have very strong update independence, meaning that we can add and remove components in any order we want. And also, of course, different applications can coexist on the same node. And finally, we support online evolution. Even the most fundamental software changes happen when the system stays online, which means that we get no service interruptions in the face of software change. If we briefly look at the alternatives in the sense network field, the two main things here are TinyOS and Contiki. And compared to TinyOS, TinyOS only supports relatively expensive image-based updates, where you either have to send a whole new image to your nodes, which is very expensive in terms of networking, or you have to send a differential patch of the image, which is very expensive in terms of the processing required to apply the update once it arrives. And of course, in TinyOS, the node has to reboot after it's applied the update. And as you've seen by comparison, in Lorien we have very, very fast, very cheap updates to software. And if we look at Contiki, Contiki only allows you, firstly, to update application level code, and secondly, it only allows you to actually load a single application at any one time. Whereas by comparison, Lorien allows you to load and unload all parts of software using exactly the same principles. In other words, Lorien is simply an OS built to evolve. Thank you for listening.